we can take 1 out of that with 1 left over, so we have that base 7. Right?
Is it okay? Is there any way we can check this?
Oh, I just have a question.
Oh, question.
How did you find the 4? I was confused.
Okay, so the 4 is 6 plus 4 is 10, plus 1 is 11.
Yeah.
And then if you take one group of 7 out of that, you have 4 left over. So you put the 4 on the bottom, you carry one group of 7 up to above the 5.
Okay.
Did you follow that?
Yeah.
Okay.
Okay, anybody else? You ready? She was going to start it, but she knew that you wanted to hear what was going through her head, so.
Alright, so you can't take 2 from 4.
You mean you can't take...
4 from 2. Yeah.
You know what you were saying, but you said it.
You can't take 4 from 2, so you have to take 1. And then you can't just take a 1, or you can't make it into a 1 because it's not base 10. So you have to add like 6 to it. So that becomes 8. And then you're left with 4. If you subtract down, and you can't take 5 from 2, so you have to
You have to what?
not borrow, take, exchange.
Make an equivalent exchange. We're going to exchange one of those in that place for what? 6 in the place to the right.
So
Okay.
that becomes 8. And then you subtract, which is a 3. And then 3 minus 1 is 2.
Okay. And we probably ought to put a little bit of subscript of 6 so that we know that it's not in base 10. Okay? Is there any way to check these answers? No? Yes?
Yes. You could like convert them all if you wanted. I don't know if there's an easier way. That would take kind of a while, but you could,
Not really, and not if you have a calculator, which you do have.
yeah.
So, you got your calculators? Just as I say it, punch it. 3, we could go times 7 to the 0, but we know that's 1, and 3 times 1 is just 3, so let's just go 3 plus 6 times 7, because it's in the 7's place, right? Plus 5 times 7 to the 2nd power. Hit enter. What'd you get? 290? Okay, now let's check this one. This is real easy to do. 5 plus 4 times 7 plus 2 times 7 squared. 131. We add this. We can do it with our calculator if you want, but 1, 2, 4, 21 in base 10. So is this number that number in base 10? How do we tell? Grab your calculator and check. 1 plus 4 times 7 plus 1 times 7 squared plus 1 times 7 cubed. Hit enter. It better be 421. That didn't take very long. Right? Okay. We can do the very same thing here. So, if you can read the number here still, but 2 plus 3 times 6 plus 4 times 6 squared gives us
164.
4 plus 5 times 6 plus 1 times 6 squared, that'd be 36 plus 34 makes 70, right? Subtract, we get 4 take away 0 is 4, 6 take away, 16 take away 7 is 9, 94 is the answer. Let's see if it is. 4 plus 3 times 6 plus 2 times 6 squared is 94. So you can walk out of the test saying, I know I got that subtraction and that addition problem right because I checked it. Now what I do not want you to do is this. I give you this problem, there's no answer there, you convert this, you convert this, then you turn this back into base 7 and write the answer there. If the problem is worth 8 points, you would get 1 point for that. I need to know that you know how to make the exchanges, because that's what we're trying to help our students do in base 10. So I don't want you to start the problem by converting and then convert back. That's to check it. I need to see these equivalent exchanges as you work the problem. Then do the check. Besides that, converting from this base 10 to this base 6 is harder than going from this base 6 to this base 10. So you might as well do the subtraction and then go back. Do you know what I'm saying? That's not why you do it that way, but I want to see that you understand the process. That's why we're doing it. It's to help you get better at that. Did that help? Okay. Anything else from the quiz? Okay. On Monday, we talked about adding and subtracting integers using two-color chips and using helping students understand it by using number patterns. I'm trying to remember, was it this class? We did a number pattern in addition. Did we do one in subtraction? So it works the same way. For minus 3. Will they know this? Yes. It's what? 1. So I'm starting at the known. 4 minus 2. Will they know the answer to that? It is 2. 4 minus 1 is 3. What's next, class?
4 minus 0.
4 minus 0. What's the answer? They'll love that one, right? 4. What should I write next? 4 minus negative 1. And all of a sudden, they're now in the unknown. Okay? You've been in the known, but the pattern has carried them into the unknown. And they're going, I don't know how to subtract integers. No problem. What's the answer? How do we know it's 5?
It's the next number up.
Because what?
It's the next number up in the pattern.
This one is minus, 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 4, 4, 4, 4, 4, 3, 2, 1, 0, so minus 1. That's how they knew that. They know this is 5 because 1, 2, 3, 4, 5. And 4 minus a negative 2 would be 6, and so on. Okay, so the number pattern also works for subtraction. And again, maybe we would start up here at this one instead. And then ask questions about when you're subtracting, when do you get 0? When you're subtracting, when do you get positive numbers? Well, when you're subtracting a number that is smaller from a number that's bigger, we get positive answers. And is that true down here? When you're subtracting, this number is smaller than that one, and we still get a positive answer, right? And they start seeing some patterns going on.
With what you just said, that's true for so far, but once you get into like the 4 minus the negative 6, you're still going to get a positive answer.
Yep.
So,
But negative 6 is still smaller than 4. Isn't it?
yes. But it doesn't, like, just visually looking at it, it doesn't look like that right off,
Yeah.
right off the bat. So how do you explain it to the students so they understand that it is smaller, or that, I don't know, like...
Everybody see what her question is? Because negative 6 to them looks like it's bigger than 4. Who's had that? I draw a number line and put 4 on it. Now where's negative 6? Up here? No, down here, right? What do we know about a number line? If you're on the right of another number, you are bigger. If you're on the left, you're smaller. So this has got to be smaller. That would be one way to help them see that it's smaller. Okay. Everybody with me? You read about some additional ways. There was a mail time metaphor where the mail carrier brings bills or checks and picks up bills or checks, which is just a finance way of thinking about integers. You also read about a hot cold cubes where you could add or take out cold or hot cubes. Does anybody have any questions about either of those, how they worked? If you understand either of those are excellent ways to approach. And then, did you read about Eli the elephant? My children, going up through elementary school, that's how they learned about negative numbers, was with the magic peanuts. Okay? And guess what grade that started in? Grade 1. Kids can understand that. Where did you learn about integers for the first time? What grade was it? 6th?
Yesterday or Monday, I went and Skyped to my brother and I was asking him, he's going into 4th grade, and I tried to show him these things, and in Tennessee they don't start integers or negative numbers till 6th grade.
6th grade. That's typical. Sometimes 7th grade, depending on where you go to school. That's the first time you see it. But kids are capable of dealing with the idea of negatives much earlier. I've got proof. My kids did it when they were in 1st and 2nd and 3rd grades through the magic peanut metaphor. Okay? What they did was they would, if they, let's say that Eli has 5 regular peanuts in his sack, and he puts in 3 magic peanuts. This is how they wrote it to begin with. They wanted them to see there was a difference. Why did they do that instead of using a -3, do you think, in this curriculum?
Oh, because that's when they're introduced to adding and subtracting. It looks like a minus symbol.
Yes, they don't want them to get mixed up with, because with the little hat on it, it looks different than a subtract. But the negative doesn't. And so that's why they did it. But they had no problems with it. So then by the time they get up into 6th grade, then they switch it over to the negative, because they want them to be able to deal with it like all the rest of the world does. And negatives are not little hats on the numbers in what most people use. So, we've got all these methods for helping kids deal with integers, adding and subtracting them, and you don't have to give them any rules at all. They make up their own rules. You were to write the rules, right, for the assignment? Who would like to read the rule that they wrote for adding 2 integers? Somebody got it? Here, handy? Pull it up on your computer, or just give it to me. Don't even read it. Just tell me the rule. You're adding 2 integers. Did everybody do this? Did anybody do this?
question? I'm sorry, my mind's not working today.
If I say, here's an integer A, and here's another integer B, and I need you to add them, what is the rule that you wrote out on how to do it? Go ahead.
Okay, so.
Listen carefully. Real loud.
Okay, so when you add two positive integers together, you will always be positive. And then any negative plus a negative will turn out to be a negative. And with that, you add the digits in the negative number like you would the positive integers, but you add a negative sign in front of the sum when you are done, when adding two negative numbers. If you are adding a negative with a positive or a positive with a negative, you subtract the smaller number from the biggest first, and then depending on which number is bigger, you place the symbol of the bigger number in front of the sum.
Okay, so I've got 3 plus negative 5. Read that last part there, and I'm going to do exactly what she says.
Okay, so you subtract the smaller number from the biggest number.
This is the smaller number.
As an absolute value.
Okay. So take the absolute values of the numbers
Yeah, and
and
subtract
subtract the smaller
from the,
of the absolute values
Yes.
from the larger.
yes.
Okay. Okay.
Okay, and then going back to the absolute value, whichever one had whichever absolute value was the biggest, whatever value they had originally, you put, or like whatever sign they had originally, you put that in front of your difference.
It's different than the way you said it before. Read it the way you said it before. Because I want to point out what kids are going to do.
Okay. You subtract the smaller number from the biggest,
Okay.
and then depending on which number is bigger, you place a symbol of the bigger number in front of the.
Which one's the bigger number? 3 is bigger than negative 5. We just learned that on number line, right? So I would put a positive on there, but do I want to do that? No. So how did you reword that now? Give it the sign of the
Absolute.
one with the largest absolute value,
Yeah.
right?
Yeah.
Which would be the negative. Okay. Now, it was obvious she knew how to add. Now, whether she was saying the rule correctly, and kids will do that. You'll be able to tell by the way they state it whether they understand it or not, but they may not be stating it totally and completely accurately. And you may need to help with that. But they'll come up with the rules themselves based on how they've done two-colored chips and how they've done the mail time problem, or how they've done Eli the elephant problem, or a hot and cold cube problem. They'll be able to do that. Okay? So we've got two-colored chips, number patterns, hot cold cubes, Eli the elephant, mail time, and I'd like to do one other thing that I like to help students with. I've given you some chips. That doesn't mean you have to use chips. That means you can if you choose to. You may choose to use Eli and his magic peanuts, or you may choose to use hot cold cubes or mail time or something else to do this problem, but do it in a concrete way. Okay? Don't just apply a rule that you memorized back in junior high. All right, here we go. Do this problem and write an answer. I want everybody to write these problems down. Do the problem. Either use two-colored chips, use mail time. And to do mail time, you can just think about it. Or hot and cold cubes, you can just think about what's happening, you know, with the, putting the cubes in or taking them out or whatever. But do it concretely. Don't just use a memorized rule. Either use your chips to manipulate it, think about the hot-cold cubes, think about the mail time, what's happening there, to put your answer down. Then, when you're done with these four, do these four. Again with a concrete model.